Hi guys, welcome to today's LTS webinar. Thank you for joining. Let me just briefly explain to you our Q&A modality for this section, and then I will pass the word to our today's speaker, Sergei. So, if you would like to ask a question, please find this Q&A box and type your question there. Sergei will answer the most interesting of your questions after his presentation. And if you want to answer Sergei's question or maybe to communicate with each other, please use the chat for this purpose. So this is pretty simple. Hope you will enjoy our today's webinar. And now I'm passing the word to Sergei Trotskyi. So I'm stop sharing my screen. Please, Sergei, start. You're welcome.
So, hello everyone. One more time, hello. My name is Sergii Trotskyi. I'm really thank you that you're attending this webinar. I have been working for Luxoft since the end of 2013. And today I would like to present you my presentation, with the topic of clustering analysis. Okay, so first of all, I will give you some introduction what is the analysis is. After that, we will have a look into the algorithm which we have, like dbscan, like k-means, etc. At the end, I will show you the method how we could compare the results, because it is very important. Because you could use different algorithms. You need to know how to compare it, and even more. So one algorithm, but sometimes we need to provide different meta parameters to it. About the code samples. I'm .NET developer, but you will not find .NET examples here. Why? I will explain. Modern frameworks are built in such a way that in order to use one of the algorithm, you just need to add 5 lines of code. The same in case if you use such frameworks as TensorFlow in Python or Scikit. Okay, so unsupervised learning. So generally, machine learning could be divided into 3 sub-studies. First one, supervised learning. Another, unsupervised learning, and reinforcement one. Okay, let's start from the supervised. Imagine that you have a room of people. Each person inside the room has its own properties, the features. It's like the eye color and so on. And every person has a label, so we could detect whether it is a man or a woman. So what is supervised learning? So this is a set of algorithms which build special classifier. And this classifier you will use next time when a new person will come into the room, And this classifier will detect whether this is a man or a woman, but based on the knowledge received from the object which we studied. Unsupervised learning. We doesn't care about the labels. We doesn't care whether the person is a man or a woman. The only one thing that we care about is about the similarities of the features. So based on its similarities, we group together objects into particular clusters. What does mean reinforcement learning? I would say that this is some kind of supervised algorithm, but it's like carrot and stick. So when your error decreases, you get a carrot. When your error increases, you get a stick. Okay, today I will present you 4 algorithms: hierarchical clustering, k-means, min-shift, dbscan. But I believe that there are 7 or even more algorithms exist. What does mean clustering? This is a process of placing data items into groups so that similar items are in the same group based on its similarities. I believe it's clear. So, time to time, it could happen the situation that your data set will not contain natural clusters. Yeah, for sure. If you would apply some algorithm here, like k-means, it will split your data set, initial data set, into some clusters. But it will not make any sense. Why? We do not do clustering just for clustering. So clustering for us is some result which we later use to make the decision. Yeah. So this information will be sent later to some business analytics, just maybe to find something new inside it. So before we move on, we need to stop a bit and we need to understand what is the distance between the objects. So actually, there are two classic methods, Euclidean one and Manhattan. Euclidean is being used in, I believe, 95% probably. Yeah, for sure, different tasks require different methods to measure the distance. For example, if we are speaking about the bioinformatics, we do not use Euclidean distance because we does not care how far one object is located from another one. What we care about is only the correlation between the features. Euclidean distance. Probably you all remember the Pythagorean theorem from the school. C square equals A square plus B square. Yeah? This could be extended to n-dimensional space. And actually, appropriate formula to calculate the distance, now you could find it on the screen. So, what is a Manhattan distance? Manhattan distance, it's like the stairs. Yeah. So, formally, this is the sum of the absolute differences. Manhattan, it has such name because of the grid layout of the streets of Manhattan. Yeah. So I draw two lines, red one and green one. Yeah, just to compare. You see the Manhattan distance will be longer than Euclidean one. Okay. In which cases do we need to use Manhattan one? Probably when you have objects of high dimension space. It means that your object contains a lot of features. It's more than 10,000, for example. Okay, so we know what is a distance already, yeah? We know what is a clustering, and let's move into the algorithm. So I would like to start from the hierarchical clustering. At the very beginning, so we have our initial data set. At the very beginning, each point is a very small cluster. What we do? First of all, what we need to do? We need to measure the distances between each points. Yeah. So on the screen, you probably see green points and gray points. Yeah. I would use only 5 points A, B, C, D, E from initial set, because otherwise my distance table will grow up too fast. So, and I will show you how this algorithm works only on that 5 points. So what we need to do, as already told, first of all, we build a symmetric matrix of distances. On each iteration, we choose 2 clusters, 2 points, which are the most closest to each other. Yeah, and combine them into one cluster. So on the picture you see that we combined separated mini cluster A and very small cluster B into one cluster, which is called AB. Yeah, for sure. These distances which we already calculated, we do not clear them, we do not erase them, because possibly somehow we will use it later. Yeah, but for us, A and B separately died, and new cluster has born. Okay, this step is repeated until we have only one huge cluster that contains every small. So let's move to second iteration. We found that next candidates for combination are points D and C from the matrix distance. Yeah, because they are the most closest to each other. So we combine them. But the question is how to calculate distance between aggregated clusters. And we have several approaches here. One of them called single linkage clustering, another complete linkage clustering. There is so-called average linkage clustering. And one more method which is called WART one, but actually I did not use it. So let's start from the single linkage clustering. The idea is very simple. The idea is that you calculate the distance by some element pair that are closest to each other. Yeah, this is the example of clustering using SLINK approach. Another approach determines a distance by element pair that are the farthest from each other. Yeah, it is called complete linkage clustering, or so-called CLINK. Now on the slide, you could see an example of clustering using the CLINK approach. So now you could compare two results. They are different. The question is why? They are different because SLINK cares only about the distances between the clusters, yeah, but it does not care about the compactness of the cluster. Yeah, compactness means how spread is data. Situation is opposite in case we use CLINK, because in this case we care only about the compactness, but we does not care about the distance between the clusters. So imagine situation that you choose SLINK. It means that distance between two aggregated clusters, such as DC and AB, will be equal to the distance between cluster C and B. So this distance we take from the distance matrix. Okay. On next iteration, we combine DC and AB into one cluster. Later, on final iteration, we combine everything into one huge cluster. So, in case if you have n element in the initial set, it means that you will have n minus 1 iteration. Advantages. You shouldn't provide any meta parameters here, yeah? And I would recommend you to use this algorithm just in case when you have some hierarchical data structure. Few words about the disadvantages. Chain effect is the main one. What does mean chain effect? It means that two clusters will be combined into one, even if naturally they are separated, but some line connecting them. Okay, let's move to another algorithm, which is called DBScan. So, at the very beginning, you need to set up two parameters, which is called epsilon and mean points. Epsilon is some radius around each of your points, the same radius for all points. Mean points refers to the number of the neighbors, the number of the neighbor elements which every point should have to become part of the cluster. So we start our algorithm with not visited point. You choose it randomly. Okay, so you see that if number of points inside the circle is equal or more, even more, than the mean points parameter, then clustering process starts or continues. In case if number of points is not enough inside our circle, we mark this point as noise. We continue this process, yeah? We continue this process for every new point which mark as such. such as belonging to the cluster. If at some stage we have not visited points, we go to the beginning of this process. We need to remember that two big mean points will lead that a lot of objects will be marked as the noise. And the same would happen if we would choose too small epsilon, yeah, if we would choose too small radius. In this picture, you see some shapes, and these shapes could be clusterized by DBSCAN algorithm easily. But the same you will not do with k-means as example. You will get into trouble in case you would try to apply this DBSCAN algorithm to a dataset which have different density. So it happens because at the every beginning you select two parameters, mean points and epsilon. Selecting the epsilon means that de facto you set the area around your point as a constant. Selecting the mean points means that you set up the number of elements inside this area, yes? And what is the density? Density is a number divided by area, which in this case will be the constant as well. So that's why different densities are a problem in case you decided to use DBSCAN algorithm. Advantages. Outliers will be marked as noise. And it is very easy to make parallel, yeah? To apply task parallel library here and so on. Disadvantages. As I already told, this algorithm does not perform very well in case you have the data set of different density. Yeah, because you set up the epsilon and you set up the mean points parameters. Okay, let's move to k-means algorithm. So k-means clustering is one of the most popular clustering algorithms, I believe, and this is the most easy. This algorithm converges very quickly to some local minimum maximum. It depends on your cost function. The most experts as I swear by k-means are absolutely hated. Why? First of all, the worst thing ever. It assumes that data points are circular. The best situation for k-means requires that each cluster, which this algorithm is able to find, should be a fixed size and completely symmetrical. One of the biggest disadvantages of this algorithm is that we need to provide the number of clusters which we would like to receive at the very beginning. In case if you have 2D data or 3D data, it's easy. We could visualize this data on the screen. But in case if you have high dimension space, high dimension objects, it is very hard to understand. So for sure, there are different algorithms such as PCA, principal component analysis. So this PCA algorithm will tell you that, for example, this, and this feature are very important and contain around 85% of information. And later you could visualize your data set using, for example, these three features, yeah, three-dimensional data. But in case if you have 10,000 features in the objects, I don't think that you will be able to reduce it to three-dimensional space. So yeah, it's a problem. This algorithm k-means at the beginning randomly initializes these centers, completely randomly. It means that from the beginning you could get totally different results. Something like this, or this, or maybe this. In order to launch the algorithm, you provided number of clusters you would like to receive. Yes. You initialize some centers randomly. Next step is to compute distance from every point from the dataset to each center. And later you should assign a point to the cluster so center is closest to it. When all points are assigned to one of the cluster, we could recalculate the position of the center by calculating the mean of the points assigned to this cluster. That's why this algorithm called k-means. K means that you should provide some value at the beginning. How many clusters we would like to receive? K. Yeah. Means that we using the means formula to calculate on every iteration the new position of the center. So we take all points from each cluster. Yeah, we just calculate some average. This average will be the new clustered center and so on. And we repeat these steps until we reach one of the two conditions. Condition number one. We reach the maximum number of iteration, which we set up at the beginning, or maybe we will repeat the steps until the group centers will not change much between the iterations. Advantages: it is pretty fast. Generally, it takes up to 100 iterations to converge. Disadvantages. So I could name following. First of all, we need to provide how many clusters there should be. We discussed already. And second, the assumption of circle nature of the cluster. Let's move on to our fourth algorithm, which is called mean shift. Please look at the screen. What do you see? Uniform data. But come on, you will never have such dataset in real projects. In real projects, you will have something like this. So right now on the screen, you see some areas with higher density, yeah, which is in the center. And you see lower density if we move from the center. Yep, it's like if you will check Google Maps and the same situation you will see around the parish. So you have a lot of roads around the parish and lower density of roads when you move from the capital. So what does this algorithm do? It moves every point to the region of higher density. For sure, somewhere we will save our initial coordinates, yeah, because we will not lose it. At the very beginning, we need to provide one metaparameter, which is called bandwidth. You could think about the bandwidth like about the radius of each point, the same as we saw in dbScan. So we choose some random point. We draw a radius around it, and using special mathematical function called KD, which is abbreviation for kernel density estimator. Yeah. So we find a direction of movement, yeah, of our point to the region with higher density. And the whole process looks like this. So on every step, we calculate this direction for each of the points. On this slide, I show you only 4 points, but it will be done for every point. Iteration M, you see this direction, you see the movement. Convergence. So we move until we converge. Converge means that points related to one cluster were moved to one small region. Yeah, it's like to climb. It's like to climb to the hill. So, advantages. This algorithm could make cluster from the data set of any shapes. So this is not a problem for it. Sometimes it is difficult to find a bandwidth, yeah, because too big bandwidth will lead, you would have one big cluster. Too small bandwidth means that every point will be considered as a cluster, yeah, so we will have the data set of clusters. How to apply this algorithm? So, some time ago, I showed this slide to the person not from IT. And the person actually asked me, what is the reason to make ugly picture on the right from the great picture on the left? And you know, imagine that you have some face detection problem and you use some neural network, yeah, you know, to identify the face. Before you will send this image to your neural network, you need to remove all extra noise. You need to remove all extra information not related. And this is the situation where the image segmentation comes into play. So, image segmentation means that you will replace each pixel with appropriate value from the center of the cluster. Yeah, so you found the cluster, you found this pixel, it will be the pixel. You took the data, you take the value of it, and you just assign this value to all elements inside the cluster. So, which methods do we have to interpret and to compare different algorithms? So, this method is called silhouette analysis. And this method you could use to compare clustering results. So, how it works? You take one point. Later, the same steps you would apply to every point in your data set. So you took the point and you calculate all distances between your point which you took and all points inside its cluster. And you take some average of it. So it's one value. Later, you take the same point and you choose one of the external clusters. You calculate all distances to the points of external cluster and take the average. The same operation you repeat with another cluster. Then you compare these average values and you choose the smaller one. So, using the formula which you currently see on the screen, you will get some value from -1 to 1. And the question is how to interpret it. Yeah? How to interpret this value. So, if value closer to 1, it means that object is on his place. You know, because the average distance inside the cluster it belongs to will be much smaller than the average distance to the closest external cluster. In case if value closer to -1, I would say that situation is quite opposite because object probably should belong to another cluster. Yeah, you know, because the average distance inside the cluster it belongs to much bigger than average distance to the closest is external one. If you use silhouette analysis, you finally will get the picture something like this. So you see that you have four shapes because you have four clusters. And if you will zoom each shape, it will contain a lot of horizontal lines. Yeah, and each horizontal line is actually this value for every point calculated by this formula. Okay, so we had a look into four different algorithms of clusterization. We had a look into some method which we could use to compare the results. Actually, from my side, that's all. And so, thank you.
Yeah,
Thank you.
thank you. Bye bye.
Thank you. Bye bye. Yeah, bye.